Hi. Okay, today we're going to learn how to solve exponential equations. We're learning to solve exponential equations, and the method we're using is to find common bases. So it's really important to be able to do, especially for next year when you learn logarithms. So to solve an exponential equation means to find the value of the variable that makes the equation true. So an exponential equation, for instance, 2 to the x equals 16. What makes it an exponential equation is that x is in the exponent, okay? So it's not like 2 times x equals 16, which is called a linear equation. It's 2 to the exponent x, or 2 to the power of x, is equal to 16, which makes it an exponential equation. Okay, so here we could just divide both sides by 2. Here you cannot do that. You have to use this strategy of having a common base. So on this side, the base is 2. So what we have to be able to do then is make 16 as a base of 2, so 2 to some power. So you get your calculator out, you know 2 times 2 is 4, so you know it's not 2 to the power of 2. You could try 2 to the power of 3, that's 8, too small. 2 to the power of 4, that's 16. So that's how I got the second step here. So now I've got 2 to the power of x equals 2 to the power of 4. So again, we can have this kind of balanced scale idea here. So on this side of the balance, we've got 2 to the power of x. And on this side of the balance, we've got 2 to the power of 4. And they've got to be equal for the balance, right? So the 2's are the same on both sides. The bases are the same. If the bases are the same, the only way to keep it balanced is if the exponents are also the same. So in order for this balance to work, if the bases are the same, they're both 2, then the exponents both have to be the same. So that would mean that, therefore, the x on this side would have to be a 4. Because then in each little bin I'd have 2 to the power of 4, which would make them equal. So that's the strategy we're going to use always, is to find the same base. So solve each exponential equation, and they'll get harder. Okay, we'll get into having to use negative exponents and getting common lower bases. So for 2a, we're starting off fairly easy. So we've got 5 to the power of x equals 125. So right away we want to think, can I write 125 as 5 to some power? So that I get the bases the same on both sides. So I already know 5 squared is 25, so I'm going to try 5 to the power of 3. And that's 125, so good. I can write 125 as 5 to the power of 3. And you guys will ask, is there an easier way to find out what power of 5 that 125 is? No. This year in grade 11, we're going to use trial and error. Next year, once you learn logarithms, it'll be a lot easier, but you have to be good at this in order to be good at logarithms. Okay, so the same numbers will come over and over again, and you'll start to get used to the fact that 125 is 5 to the power of 3. If it feels awkward now and you're using your calculator a lot, that's good, because the more you practice, the more some numbers will just stick in your head. Okay, like everybody knows that 4 squared is 16 and 5 squared is 25. You'll start to get that way with cubes and powers of 2 and things that you use a lot of. Okay, so now we've got the same base on both sides. So once I have the same base on both sides, the exponents have to be equal. So I usually do a therefore statement saying that if the bases are the same on both sides, therefore the exponents have to be the same. And in this case, it's that easy. X has to be 3. So the solution is that the solution of the exponential equation 5 to the x equals 125 is x equals 3. So it's got a solution, okay, much like a linear equation. In this case, it just has one solution, okay? 3 to the x, 3 to the power of x equals 1/9. So the first thing is, in order to get the same base on both sides, I don't want this 9 in the denominator and this 3 in the numerator. So my first step would be to write 1/9 as 9 to the negative 1. So take a second to wrap your head around that. Everyone agree that 9 to the negative 1 using our negative exponent rule is the same as 1 over 9 to the positive 1. Okay? So now I want to get the same base of 3 on both sides. So I want to just think about the 9 right now. Ignore the negative 1 for a second, but you'll see where it comes in. Is there a way to write 9 as a power of 3? Yes, 9 is the same as 3 squared, 3 to the power of 2. But that's still, so all I'm doing is replacing 9 with 3 squared, but that's still to the power of negative 1. So now I've got on this side a power to an exponent, and that's a rule we learned last time as well, that you keep the base 3 and you multiply the exponents. 2 times negative 1 is negative 2. So again, let's refer back to last lesson. 3 to the negative 2, if that was a question for you, you would have said, okay, I know that's 1 over 3 to the positive 2 using the negative exponent rule, which is 1/9. So again, we started with 1/9 and we rewrote it as 3 to the negative 2. So everything's okay. Why did we do that? Because now it makes it really easy to solve the exponential equation. 3 to what power, x, is the same as 3 to the power of negative 2? Well, if the bases are the same, the exponents have to be the same. So our solution would be that x is negative 2. Okay, so C, we're going to use a very similar strategy. So 4 to the power of x, and 64 is in the denominator, so I'm going to bring it up to the numerator and make its exponent negative 1. Now I would really like it if I could get a common base, so if I could get a base of 4 on both sides. So I'm going to be working with a 64 and my calculator. So 4 to the power of 2, most of you know that's 16. So let's try 4 to the power of 3, 64. So I know that I can write 64 as 4 to the power of 3, but that's still to the negative 1. So then I can use my power to an exponent rule, which says keep the base and multiply the exponents. 3 times negative 1 is negative 3. Now I've got a common base on both sides. The only way the two sides can be the same if they have a common base is if their exponents are also equal. So x must be negative 3, and that would be the solution. X equals negative 3. Okay, so 4 to the power of x equals 32. So this one looks easy, but I'm going to put a little star here because this is one where we need a common lower base. Because once we try, we know 4 squared, 4 to the power of 2 is 16, which is less than 32, but 4 to the power of 3 is 64, which is more than 32. So I can't write 32 as 4 to the something. So there must be a common lower base, and that lower base is 2. So I can rewrite 4 as 2 to the power of 2, but that's still to the power of x. And then I'm going to hope that I can write 32 as 2 to some power. So let's try 2 to the 3rd, 8, 2 to the 4th, 16, 2 to the 5th, 32. So 32 can be rewritten as 2 to the 5th. And then on this side I have a power to an exponent. So the rule says to keep the base the same, 2, and multiply the exponent. So 2 times x. 2 times x is 2x, way back to grade 9 math there. 2 times x is 2x. And on this side I have 2 to the 5th. So now I have the same base on both sides. It's a common lower base of 2. So if the bases are the same, the only way the equation can be true is if the exponents are also the same. So if the bases are the same, to be equal, the exponents have to be the same. But I'm not going to box up that answer because that's not saying what x is, that's saying what 2x is. So now to get x by itself, I do divide both sides by 2. And then I would get x equals 5 over 2. as my solution. Oops, x equals 5 over 2 is my solution. So try that on your calculator and see if 4 to the power of 5 over 2 does give you 32. So 4 to the power of bracket 5 divided by 2, closing bracket, is 32. Okay? All right, next one. So this one's a little trickier because we've got our exponential term isn't by itself, so we want to get it by itself. So we're going to start off by dividing both sides by -4. So -4 divided by -4 is 1. So now on this side we just have our exponential term, 3 to the x. And on the right side we get +9 because -36 divided by -4 is +9. And then is it possible to write 9 as a power of 3? It is. 9 is the same as 3 squared. Same base on both sides, so therefore the exponent, x in this case, has to equal the exponent on the right side, which is 2, and then we don't have to do anything else to get x by itself. Okay, so for f, 7 to the x plus 3 is equal to 49. All right, so in this case again, it is possible to write 49 as 7 to the power of 2 in this case, 7 squared. So we've got the same base on both sides. So the only way that this equality can hold true is if the exponents equal each other. But we don't want to know what x plus 3 is, we want to know what x is. So to get x by itself, we would subtract 3 on both sides in this case. And we get that x is -1. And you can see if you put x as -1 in here, you would get -1 plus 3, which is 2. 7 squared then is 49. It's true. Okay, G. So now we're got a little more complicated here. We have an x on both sides. So we've got 5 to the 2x equals, so we're hoping that 125 can be written with a base of 5. So you might remember it, but 5 to the 3rd is 125, so I can rewrite 125 as 5 to the power of 3, and that's to the x plus 4. So I'm going to put a star beside this one as well. Because when you multiply, when you have a power to an exponent, you multiply, but we're multiplying 3 by x plus 4. So you have to use the distributive property and multiply the 3 by the x and the 3 by the 4. So you're going to get 5 to the 3x plus 12. So a really common mistake would be to write 5 to the 3x plus 4 and forget to multiply the 3 by the 4 as well. So now since we have the same bases on both sides, the exponents have to be equal. And remember, what we want to do is figure out what x equals. When you're solving an equation, you're solving for x. So now we've turned it into a little grade 9 equation. So we're going to subtract 3x on both sides to get the x's together. So that's going to give us -1x or -x. Divide both sides by -1, and we get x equal to -12. All right, H, 9 to the 6x equals 1 over 27. So first off, I would rewrite 1 over 27 as 27 to the -1. It would be nice if I could get a base of 9, but 9 squared is already 81, which is bigger than 27. So there has to be a common lower base. And that common lower base is going to be 3. So I can write 9 as 3 to the power of 2, still to the 6x. And I can write 27, 3 to the power of 3 is 27. 3 to the power of 3, but that's still to the -1. Then I can use my power to an exponent rule, which says to keep the base and multiply the exponent. So 2 times 6x is 12x. and 3 times negative 1 is negative 3. So now I've got the same base on both sides. So therefore the exponents must be equal. But I'm solving for x because I'm solving an equation, so I want to divide both sides by 12. And negative 3/12 reduces to negative 1/4. So there's my solution. And my last one, so it's kind of combining all things. There's going to be a common smaller base involved. X is on both sides. This is kind of as hard as it gets until next week when we learn fractional exponents. Okay, so we've got 4 to the 2x minus 1. So the first thing I want to do is bring the 8 up to the top, but then it's going to have to be to the exponent negative 1. So before I do anything else, I want to deal with that exponent negative 1 by distributing it. So that's going to make it 8 to the negative x minus 5. So again, I'd be trying to get a common base of 4, but 4 to the power of 2 is already bigger than 8. It's 16, so there has to be a common smaller base. And that's going to be 2. So that means I want to write 4 as 2 to the something. So most of us know that 2 squared is 4, but that's still to the 2x minus 1. And then what you may not know right off the top of your head is that 2 to the third is 8. So I can rewrite 8 as 2 to the third, but that's still to the negative x minus 5. So now we can use our power to an exponent. So keep the base and multiply the exponent, and that's going to be on both sides. So 2 to the 4x minus 2 is equal to 2 to the negative 3x minus 15. So finally, after all that work, I've got the exact same base on both sides. So I've got base to an exponent equals base to an exponent. And the only way for that to be true when they're the same base is that the exponents are also equal to each other. And then I've got a grade 9 equation again, so I'm going to add 3x to both sides. Add 2 to both sides. And divide both sides by 7. So finally I get x is negative 13 over 7 is the solution of the exponential equation. All right, so that's solving exponential equations. And our success criteria is I can solve an exponential equation by finding common bases and then setting the exponents equal to each other.